Okay, guys, here today you start the module 5, the related to the project management and software engineering. Today we will start the análise de requerimento e conceitos básicos. This part has two activities, okay? This content has two parts. The first one is the Unit 6.1 project management process, and the second part is requirements engineering, okay? The idea today is to finalize this part here, and the next class, next week, or on next class, I believe we will start this topic to this week and finalize next week, okay? Just remember that we have two classes this week. Give me a second to see here. Starting now, it's 532 here. We have the class today, and we have the two first class Wednesday, okay? We use, I believe the second part we start today, start next week and finalize in the beginning of the next week, okay? The contents that we study today, we don't use this week in the rapid development, we use the next week, okay? So, the goal of this class today is to describe what is a project management and discuss the key elements in the project management framework. The first thing is, why do I need project management? It's very important. Before, who already has some skills or work in a project, for example, that the people use a formal methodology to organize the work? Who already knows, for example, about the Scrum or Agile or something like that? Are there some okay. Sorry,
the leader of the team leader is the one that has to implement and to know about those things, no?
Oh, nice, nice. Thank you. Any other? Who more? Nope. Okay. So why project management is important? Okay. The first thing is around 10% of every dollar is wasted due to the poor project performance. A lot of projects that exist today is not well organized, it's not well performed because the people don't use correctly the project management tools. Another one, 32% of the budget is lost when the project fails to reach its goal. You see today that the one thing that the project methodology is looking for is to try to take off the waste inside the project. You see, any project, you have a lot of activities that don't follow to the target. For example, things that you need to develop, I don't know, a library, okay? One library to calculate a number plus another number, okay? It is what your boss wants. However, you spend a lot of time thinking about, for example, the GUI, and spend a lot of time to develop the best UI that you can. However, when you submit or you deliver that fact to your boss, and the boss say, I don't ask exactly to have a UI. I want to use only the library part, the code part. because I sent to another group to develop the GUI. It's one thing that happens a lot. You spend time with things that is not exactly the target, okay? Another problem, around 40% of the project fail due to change in organization priorities. There are methodologies that you, for example, you see the water flow methodology of water flow approach. You design the requirement first and you implement late, okay? You design the requirements, you design the model, the logic model, you design the implementation model, and you codify, okay? You follow these 4 steps, and you test in the final. And you spend a lot of time to design the requirement, to understand the requirement. But when you finalize this step, you start to work, okay? And you spend, for example, 2 or 3 months to design the requirement. And what happens? 90% of the project, the user don't know exactly what you want in the beginning of the project. He understands the project during the project. For example, you want to create the car that the Uber car that fly, okay? In the beginning of this project, 5 years ago, 6 years ago, the people don't have a very good understanding what it means. Now the people understand, oh, the Uber that fly has this behavior, has these characteristics, okay? Now you know, but 5 years ago, you don't know exactly. You have a very big picture about what you need to develop. If you spend a lot of time to design the requirement that time, you need to redesign again now, okay? It's what happens because sometimes the organization priority change. Around 50% too of the complete project experience high scope creep. I believe you have a picture here. You spend a lot of time to design script. Okay. And finally, around 70% of the organization outsource their project to third party. Okay, a lot of work now is to send the risk of the project, to delegate the risk of the project to another part. So in 1995, Stanley's group study published this sentence here. IT projects have a terrible track record. Only around 7% of the IT projects were successful, and over 31% were canceled before the completion, costing around $81 billion in US. It's a very, very bad number. Again, now it's changed a lot. Remember, in 1995, the methodology that you use to develop system is not like the methodology that you use today. In that time, you use the RUP, okay, the rule, or the rational unifying process. The rational unified process is a nice process to document the development, but is a trash to generate code. In this methodology, the IOP, you spend a lot of time designing things, and you don't have time to develop the codifying the things that you design. You don't have a lot of time because you need to generate a lot of documents, a lot of models to do everything. Okay. In that time, a lot of projects, only 6% finalize successful. And the project that finalized, only 31 were canceled or put to the trash. The reason is very easy to understand, because What happened that time? You spend a lot of time to generate documents, and don't. The worst part is, for things about that. You want to buy a car because you need to go, for example, to your home, to your school every year. And you want to buy a car. And you have the money. You have everything. You have the money. You have the license. You need a car. And you go to the mall and the guy said, oh, give me time. I will develop the best car that you can receive. Okay? In the first week, you receive a paper. Oh, it's the picture that I designed to your car. Oh, nice. Okay. You pay, for example, 5% of the car. The next week, oh, here is a lot of it's another document that I designed the best, uh, the best safety part of the car. And repeat, and you pay more 10%. When you have at the end of the development, in the last month, you have only 10% of the money to pay. And you don't have, and you didn't see the car yet. Okay? You expect that the mall give you the car in the last week. But a lot of times the car is not, because you don't have a lot of time to develop the car. The car is a bad car. Okay, it's what happened in the code. Use this methodology. It's a very common methodology in 995. If you use this methodology, you generate a lot of papers. When you finally you need to implement the code, you don't have a lot of time because you spend the time generate documentation. Okay, it's the reason that a lot of time you can finalize the project. And when you finalize the project, you spend so many times to design things, to document things. Then when you deliver the car or deliver the project don't make more sense. Or it's because it's obsolete, or it's because you don't want anymore. Okay, any questions?
No, for now.
Oops. But what is a project? It's very important to understand what is project, what is not a project, because sometimes if you make confusion, you use the wrong tools to support a project or wrong tools to support a no project. A project, the main important concept in a project is here. Is a temporary endeavor, okay? Is a temporary. A project is not permanent. You can, for example, if every day you need to check the security, for example, think about the server administration, okay? Every day, the sysadmin need to check the accounts, need to check the security, need to check the printers, every day, okay? It's not temporary. Another character is, it's not a unique product. Every day you see the same thing, okay? In this case, it's not a project because a project is temporary and generates a unique product or service. One example of project. For example, a class can be a project. What do you think? A course, a tech course can be a project. What do you think? Yes or no?
The course itself, I don't think so. Because it repeats again and again the course itself. But maybe a project within the course, it may, well, of course, be a project, maybe homeworks or something like that, maybe something special that it's made during the course, it may be a project, but the course itself, I don't think so. Well, at least that's my opinion.
Thank you, Gustavo. Any other comments, guys? What do you think? It is a project or not a project? Okay. You are correct, Gustavo, because you repeat every time the same content, more or less. Okay, it's not completely wrong to understand that the project, sorry, that the course is not a project. However, if you see using a different perspective, you can see too, then the course is a project because the student is different. Okay, every year the student is different. And because the students is different, you need to have a different approach to teach the same thing. You can say, oh, the final project of the final product or service is different because the student is different, okay? But you are correct. If you see seeing the course as a repeatedly activity is not a project, okay? But if you think, for example, that a course, for example, 521, you is not here in the same course next week, next year. Maybe it's a temporary, you can understand that it's a temporary endeavor. And the product or service is different because all the times you need to adjust the cost to the audience. Okay?
Okay, I see.
Okay. So, unique purpose, temporary, require resource, have a primary sponsor or customer, involve uncertainty. Okay? Each characteristic that a project has. A project has some constraint. The first one is scope goals. What is the project trying to accomplish? Things that the course is a project. What's the scope goals? Is to, at the end of the course, all the students can develop the repo. Okay? Time goals. How long should I take to complete? Time goals, for example, I need to do this course in, I believe, 10 weeks, if I'm not wrong. Cost goals. What should it cost? For example, when you prepare the course, for example, you have some professor, you need to pay the professors. You cannot get another professor to teach, okay? You have some restrictions to the constraints to the course. And the project manager has the duty to balance these three often competition goals. Because if you see, you need to accomplish one target. And sometimes you need to adjust the time. You need to work more or we need to work less. And, or for example, oh, I need more people, but you don't have money. The project manager, the PM, need to hand and to balance these three often competition goals. Okay. There are a book, The Death March. Okay. This book is written by Edward Jordan. Did you listen before about the Edward Jordan or not? It's the first time. Is it the first time that
The
you
first time.
Okay. Did you listen about the OML? Yes or no?
Yes,
About that
we have
language.
used,
Okay.
yes, we have used the UML diagrams to organize
Yes.
classes in C++.
Yes. Okay. The UML is a language notation to design to design a code, a project inside the object-oriented paradigm, okay, using OOP. This language or this, it's not exactly a language, but it's a pseudo language, UML, notation language, is developed for three guys, okay? That the name is the Gang of Three. I show you. Give me a second. Did you see my screen or not?
Yes.
Sí.
Okay, I found. The UML was designed by these three guys, okay? The first version, okay? Jacobson, Humba, and Grade Bloch, okay? It's the reason and, oh my gosh. And Warden is one guy that developed a lot of things in the regional unifying process too, okay? And the reason to design these things, the order is a very, today the people don't know, but in the beginning of the 19 and 18, 90 years, is a very famous software engineer guy, okay? And he developed this book, is the Deaf Math. This book is a technical book, but is written like a history, like a romance, okay? It's very easy to read and very thin, this book. And this book is talk about the mission impossible. What is a mission impossible? A mission impossible is a project that does not have enough cost or does not have enough money, or the scope is very big, or the time is not sufficient to develop the scope or consider the cost, okay? If you don't have one of these three constraints controller, you have a mission impossible. Follow the definition of your, okay? It's very simple. I don't have money enough to develop the things. The project is impossible. If you don't have enough money, you don't deliver everything that you need. Or the scope is very, very, very big, okay? If the scope is very, very big or is very, very complex, you have another problem, okay? You can have the money, you can have the time, but if the scope is complex, you cannot accomplish the goal. Or you have the money, the scope is correct, but you don't have time. The time that you have to finalize the project is very short, okay? In this three situation, the project is impossible to finalize, okay? This book is very famous in the software engineering. Any questions?
Not for now, teacher.
A project manager is the application of knowledge, skill, and tools and techniques to project activities in order to meet a project requirements. A project manager is a methodology, okay? Is a set of tasks, a set of activities to develop, to acquire the meet project requirements or the project requirements, okay? There is a very famous book, is the PM book guide that define a lot of good practices to use inside the project manager, including there is a certification about this best practice. Okay, you can take certification, PM book certification. Okay, to certify project managers. So, what is a software development process? Okay, we'll talk about the project manager is a big, okay? The project manager involve a lot of different activities. For example, you can have a project that has developed of hardware, develop of software, develop of network, and integration part that integrate the three parts of the project. You use the project manage techniques to manage the project like that. But inside the software part, you have the software development process that only take care about the software development. Okay, this software development process is the thing that we use in our course this semester. Software specification is the first step. The software specification is the functionality of you define the functionality of the software and constraint that the operation must be defined. For example, I want that my software calculate one number plus another number is a functionality. Okay, you can have a constraint. Okay, I want that my software calculate one number plus another number in 30 seconds or 30 microseconds. Okay, it's a constraint. Okay, the function requirement is I want a function that calculates x plus x. Okay, and the restriction is it needs to be in 10 microseconds. Okay. The second, the name of this set of these activities, the definition what the system needs to do and the constraints is the software specification. You will study about this process in detail next week. Next class. The second part is the software design and implementation. So in the first part, you define the requirements. In the second part, you start to design the software, okay? For example, I use 3 components to finalize, I organize my features in component 1, has the feature 1, 2, 3, component 2, 5, 6, 7, and the feature and the component 3, you design how you solve the problem in software components, okay? And you codify these components in the real code, in C++, Java, Python, and others. Okay. The third step is the software validation. The software validation, you get the specification and you get your code and confirm one to other. Okay, this requirement A is implemented in the code. Yes, it's this part here. This requirement 2. It's implementing this code. Yes, is this part of the code here. Okay, you validate you validate that this guy here is equal or acquire the requirements that is defined here. And the final is the software evaluation. Okay, After you finalize your coding, here you have a product, okay? But the software is a live thing, okay? Every time you need to upgrade, see your Office, see your Linux, or see your Windows. For example, after you deliver your software, you found bugs, for example. Oh, when you calculate A and B, the result is okay. But when you calculate A and C, you have some issues or some errors, okay? The software evaluation detects these things and you have the upgrade of the software. Any questions? All the time, the software developer follow these 4 steps, okay? Sometimes you divide, for example, the first step you divide in 2, 3 steps, sub-steps, but in the general way, you have this 4 stage. And what you change, how you implement these things. The first model is the water flow model, okay? In the water flow model, you define the requirements after you design the system and software. The next step, you implement in unit test, you generate the integration, and you define the operation and maintenance. What's the problem of this approach? For example, if you have some problem, you only can see this problem here because you start to testing this code only when you arrive in the implementation unit test. Before it, you didn't generate one line of test. And the problem is, things that you start to work today in design the things, get the requirement, design the system, and start to codify. When you 6 months or 1 year ago, you'll be ready because you finalize this part here. Okay, you're ready to test. You see, oh, I have a lot of problems. I need to fix my design. If you need to fix your design, it means that you lost a lot of time. You need to rework a lot. Okay, so this process is not so good because you spend a lot of time to discover bugs in your code. Any questions? Did you understand? Yes, hello.
Yes, teacher.
And this core, okay, this graph show the problem. For example, cost of the change. If you discover the problem in the beginning of the project, the cost is very low. But if you discover the problem here, the cost, for example, during the production, the cost is very, very expensive. Okay. Another approach is the incremental model. The incremental model is like the first one, the waterfall. What changed is that you divide the waterfall process in a lot of incrementation. For example, in the first increment, you put the focus only in the part A of the requirements, okay? You planning, you modeling, you building, deployment, testing, and you start the second increment, for example. In the second increment, you check the code again to the requirements again, see, oh, I need to implement this thing here. And you plan, model, construct, and build. You will do it until the system is complete, okay? The problem is the same than last one. For example, if you found the problem in the modeling here, you lost all the other 2 steps before. The Boltzmann and the spiral model is a little different because in the spiral model, you increase the complexity and the scope interactively in spiral, okay? It's similar than the first one, but you, for example, the difference is in the big, you don't do all the steps in all the spiral. You increase the complexity of the process and follow the how many times you run in the spiral. Okay, it's different here. And here in the beginning, we implement all the phase. In the second step, we implement all the phase. In the third one, implement all the phase. Here, oh sorry, here, no. You increase the things that you do in interaction, and spiral on spiral. So, and the problem of the two process, the three first process, is you spend a lot of time to discover the problems. Things here, okay, in this interaction here. If you discover, for example, only the bug in the operation prototype, you spend all of the other process. Or say, in other words, if you discover the bug here, you lost everything. No, sorry. You lost sometimes everything that's coming first. Okay. Because this reason, the best approach changed. Okay. And you start to have the Agile Software Development Manifesto. The first manifesto is individual interactions over process and tools. Did you remember that I told that the most common methodology in the 18-19 years was the rational unified process? And this process generates a lot of documents, but don't generate code, okay? The first manifesto is individual interaction over process tool. Because that tool, that methodology has a very complex tool to model the system, okay? Working software over comprehensive documents. If you work with the software, you want to generate software, not to generate documents, okay? Follow this approach, you're looking for working software. You're looking for generating software, not documents, okay? You generate document, yes, you generate document, but not a lot. Customer collaboration over contract negotiation. In the previous approach, you have a contract, okay, that you sign in the beginning of the project, and you follow the plan. In the Agile methodology, you change this paradigm. Your customer is your partner to generate the best code. It's not only the guy that pay you, but it's the guy that pay you, but share the expectative or share the risk with you. The last part is respond to change over follow a plan. In the Agile, the plan is important. Yes, the plan is important. But what's more important is to acquire the user requirements. And I told you, in the beginning of the project, the user don't know exactly what he wants. Okay? It's the reason that you don't spend a lot of time in the beginning. You work with your user. During the project, you get the complementary information that's required to develop the system. Any questions, guys? No questions?
No, de momento.
No for now.
There are 12 Agile principles. First, satisfy the customer. It's most important that follow the contract, okay? It's not means that the Agile project do not have a contract because it's impossible, because the requirement change. No, but if you need to change a requirement to the satisfaction of the customer, you change. It's no matter what you wrote in the contract. It's outcome change. Again, the user will be better to improve what you want during the project, not in the beginning. Okay, it's the reason that outcome change. 3, delivery frequent. You develop code all the time, and the deliverables is frequently. Okay, for example, 2 weeks, you send some code to the users. Not only any code, no, a code that is important to users. Work together. There is there is a rule in the Agile that you work with your peer. For example, you have one guy working and the other checking, making tests about the code that the one guy generated. Trust and support. In the Agile, there is no boss, okay? The people trust and support each other, okay? The face-to-face conversation, another thing, important thing. It's much better than to use videos and all that, but it's changed now because the pandemic, face-to-face conversation is not so easy today. It's the reason that you try to emulate this part, use a Zoom and others. Go for it. Working software. These methodologies, the focus is the software, okay? You need to design, you need to deliver codes, okay? Working software, then to generate documentation. Sustainable development. Okay, you have some, you need to pay about your team, okay? You don't want your team works hard, then it's broken and I don't want to work anymore, okay? You generate sustainable development, okay? You generate a number of products that you submit or to deliver a month or 15 days or month by month. Continuous attention. You need to work together. You need to work attention because your partner depends on your work. If you didn't accomplish your task, the project failed, okay? Maintain simplicity. The code and the project methodology need to be easy to use, okay? You see the Scrum late, and the Scrum is nothing more than the Agile that follow these 12 steps. Self-organized teams. In the Scrum or in the Agile, those who do not have a boss, the teams self-organized, okay? Reflect and adjust. You need to criticize your test, for example, reflect what you're doing wrong. I need to submit this part of the code and I cannot accomplish. I could not accomplish. What is wrong? Okay, you need to reflect and adjust what is wrong. Any questions, guys? Just for finalize, this comparison of again the waterfall and agile. In the waterfall, you plan, you design, you build, you test, correct, and test, deploy. Okay, if you found a problem here, you need to redo all the steps before. The plan, the design, the build again. If you found the problem here, you do the correct, the test, the build, the design, and the plan. Okay? In Agile, In Agile, you plan and you design, build, and test. You plan, you design, build, and test, deploy. You plan, you design, build, test, deploy. What changed in the Agile is, remember, useful software, okay? It means that you generate code that is important to your user. And it happens in a very short time, 50 days or 30 days. Another example, the waterfall and Agile. And the waterfall, the difference is you pay to receive the bonus. Here, you pay in the Agile, you pay and developer, you pay and developer, and you pay and developer. See what happens in the DICE. Remember, DICE is means risk, means uncertainty, and the uncertainty is decreasing in the time. It's like the money. The money is not bigger in the beginning or to the end. You keep it controlled. Okay? Did you understand this picture here, guys? Yes or no?
Yes.
Yes.
Okay. After the break, I will give you another break. After the break, you start the Scrum Foundations, okay? Any other